I wanted to make a quick video showing SN curves as you might see them in scientific studies if you're really interested in the mechanical properties of specific tissues. So this is an SN, well, it's a set of SN curves from cortical bone loaded in compression, in tension, and in shear. And one thing to notice about this plot, and you'll see this commonly in engineering plots, is the stress is also plotted on a log scale. So notice that we go from 25 to 50, from 50 to 100, from 100 to 200. So that's why it's a straight line, meaning that's why these are straight lines. If you plotted that y-axis not on a log scale, you would get the kind of exponential power law that I sketched out in previous charts. So something to notice about this plot that I thought was very cool was that it shows you that for bone, the strength of bone is substantially different depending on how you load it. So these are three modes of mechanical loading that we're familiar with from previous videos, right? Compression, that's, say you have a bone like this. Draw a little cross-section of a bone. Compression, that's loading it like this. Bone is very strong, meaning for a given amount of stress, it can survive many loading cycles until it fails. In tension, that's like trying to pull the bone apart like that. Fewer loading cycles, right? So for this amount of stress, far fewer loading cycles of failure than for compression. In fact, it looks like if we extrapolate the compression curve, it would take, at 100 megapascals of loading, it might take, what is that, 10 to the 6th over 10 to the 6th versus in tension only 10 to the 2nd. So 100 versus, what is that, a million? Huge difference in mechanical strength. And then for shear, that's, if you recall, shear stress is when you have forces, it's like tension, but the forces are offset. So this might be shear force. It would have the tendency to crack the bone like this, right? Because the top half of the bone wants to go this way, the bottom half wants to go this way. In shear, bone is incredibly weak. So look how few loading cycles it takes to injury. In fact, it suggests that at just one loading cycle at whatever this is, 60 would break it. So I thought this was pretty cool, and I wanted to also introduce the idea of sometimes you'll see people doing a log scale on the y-axis as well. But this is SN curve for an actual sample of biological tissues, and I thought it might be interesting to see.